Okay, this is the 2013 higher level question 3. So the axonometric axis required for the isometric projection of a toy truck are shown. The elevation, end view and 3D graphic of the truck are also shown. A. Draw an axonometric axis as shown. 2. Draw the given elevation inclined at 15 degrees as shown. Draw the given end view inclined at 15 degrees as shown. Draw the completed axonometric projection of the toy truck. Okay, so first of all, what I'm going to do, I'm going to draw my axonometric axis, which is this vertical line, and 30 degrees to the left and 30 degrees to the right. So on my sheet, I just got the very center of it. So here's the center of my sheet. From there, we're going to draw a vertical line. These are the axes, remember. Line at 30 degrees to the left and a line at 30 degrees to the right. Okay, so that's my axis that Dave asked for. Okay, next I'm going to draw my elevation up to the left. So what I'm going to do, I'm going to continue my line from the right at 30 degrees up here. Okay, now what I'm going to do first is draw a vertical line. Now from there, it says that it's inclined at 15 degrees. So I could use my protractor, but I could also use my set squares. So the way the set squares work is 30 degree set square on the t-square, and then line up your 45 on top. That angle there is 15 degrees. Yep. Then I can turn my set square the opposite way, and that'll give me the line 90 degrees to that. And this is where my elevation will fit in. Okay. Now I'm going to draw my end view at the other side. So I'm going to project out my line at 30 degrees. Out here. Just by reference there, I left about 60 mil, 60 mil between the axis and the corner of my elevation. So I'm going to do the same thing at the other side, about 60 mil. Shouldn't really matter too much. Again, I'm going to do the same thing. 60 degrees. This time it's going the opposite way. 45 degrees set square up against it. There's my line at 15 degrees. And then this line is perpendicular to this line. So this is going to give me the line for the bottom of the end view. So this is where my elevation and end view are going to fit in, and they're 90 degrees to each other there, just to see, 90 degrees. Okay, all it's a case of doing now is using my dimensions to draw the elevation and the end view. Okay, maybe. Okay, the next part that I'm going to draw now is I'm going to start with the 3D drawing of the wheels here, these first set of wheels. So in our elevation, this is what we're going to be drawing, 2 semicircles, and in our end view, this is where they appear. So it's like you're looking at the front of the toy truck, looking in this way, the wheels would appear as this rectangle here, which of course is the curved surface. Okay. So what I'm going to do is in our elevation, I'm going to split up the semicircles that create the wheels. Okay, so I've showed you before how to divide up a semicircle using your compass, or a circle for that matter. Okay, so what I'm going to do is get the radius of the semicircle, 17 millimeters. Then I'm going to go to the top of the semicircle, scribe an arc, Go to the bottom of the semicircle, scribe an arc, go to the middle of the semicircle, scribe an arc, and scribe an arc on top as well. So what that has done is it has divided my semicircle into equal parts. I'm just going to join that to the center of the circle. Okay. So those points, I'm going to call them 1, 2, 3, 4, 5, 6, and 7. Okay, so they're going to appear on this line and this line for our track. Okay, so at the moment we have point number 1 and point number 7. They're at the bottom on the ground. So point 1 is on the ground. And point 7 is 34 millimeters up. So what we're going to have to do, we're going to have to get the heights of how far 2, 3, 4, 5, 6 is off the ground. Okay, so what I'm going to do, I'm going to use my 15 degrees as well, again. And I'm going to project the lines onto the ground. So I'm just going to use blue for that. These are the heights that I'm going to use to locate the points in our end view. Okay, so what I'm going to do, I'm going to get my compass and whatever the distance is from the ground up to the point, I'm going to get that in my compass and mark that from the ground up. Okay, so 2 millimeters is our point number 2. I'm just going to measure it. It's 2 millimeters. It's not big enough for me to mark in with my compass. So that's point 2. Now I'm going to go 3. Point number 4 is next. Which is halfway. So I can just extend that line across actually, make it easier for myself. So 3, 4. Point number 5 is next. Getting that height. And then lastly is number 6. So I'm going to take it from the XY line or the ground up to the point. Okay, so now I've located all of my points. So points 1 to 7 in my elevation and my end view. Now all it's a case of doing is projecting down all of those points into where the 3D graphic is going to be. Okay, so they're going to be projected down at 30 degrees from the right and 30 degrees from the left. So I'm going to start with number 1. So there's number 1, 2, and then number 7 is the last one here. Project it down. Okay, just going to draw those lines in there. I'm just going to make sure that 7 and 1 are directly above each other, which they are. So now I'm going to join these as a freehand curve. Okay, so that is the first curve done. Now what I need to do is I need to create another curve here. So what I'm going to do is I'm going to get the distance from 1 across to the other side of the wheel. Okay, that distance there, I think it's 15 millimeters. I'm going to get that in my compass. And I'm going to mark that across from all of the points that I got already to get the other side of the wheel. So 7, 6, 5, 4, 3. Okay, that's all I need to do, because then it kind of disappears underneath itself. And again, I'm going to draw in a freehand curve. And that is then just draw a line to 30 degrees, kind of tangential to it, and that's going to be the curve. Okay, next what I need to do, I need to draw the back portion of it. Okay, so again, this radius for the front of the wheel is going to be the same as the back. So all I need to do is, I'm still going to project down at this line, so all of the points are going to be along here. And what I'm going to do, I'm going to locate all of these points on this side. So, okay, so I got cut off there. What I did was I located all the points on the other side of the curve by locating points 1 to 7 on the elevation, and then I projected them down, and they're going to be on the same projection lines as the other side. Okay, next what I'm going to look at is the tipper. So this area here. So I'm going to locate that just with yellow on all of my views, just to make it a bit more clear for this in the video. And remember, with axonometric we don't have any hidden detail. Okay, so that's the tipper in the elevation. In the end view then, it's the one that's 16 millimeters wide. It's a little bit shorter than the cab. It's at 12 millimeters shorter. Okay, so I'm going to locate that next by projecting down from the elevation. This corresponds to the front corner here. That's one line. Where it ends is from back here. Okay, so that's the first baseline, and you can keep referring back to the drawing on the question, because it'll always look similar enough to that. Okay, next I'm going to get the top of the tipper. So I'm going to project down from my elevation. I'm going to locate that top on here, so it's up here. I'm going to project that back. And I'm going to join these up. You'll see it taking shape there slowly but surely. Okay, that's the far corner. So that goes across here. And then the near top corner is this point here, project it down. Okay, I'm actually not going to fill in the rest of that now until I have the cab complete, because I know that the cab is going to start my view of the tipper. So I'm just going to leave it for now. Okay. I actually have one more line to put in here. So this is the back surface of the tipper, which is sloped. This is where it is in my end view. So I can just project down at that angle to where it hits that point. Again, I'm going to heavy it into the corner, but it stops there. That's important. So I'm just going to heavy in a little bit, because I know, as I said, that the cab is going to start my view. Next, what I'm going to do is I'm going to focus on the curve in the cab. Okay, so this is made up of a quarter of a circle. So again, what I'm going to have to do is split up my view. So I'm going to get the radius of the curve, go to the top of the curve, mark off an arc, go to the bottom of the curve, mark off an arc. Okay, now I have a few points on my cab. So I'm going to call them A, B, C, D, and then there's a horizontal part there that goes across to E. Okay, then it kind of goes down we'll worry about that when we get there. Okay, again, same procedure as for 1 to 7. What I'm going to have to do is I'm going to have to get the heights from my elevation and bring them over to my in view. So again, just going to bring a line down to the ground, and these are the heights that I'm going to use. D, I already have it located, it's up the very top. So finding the curves, A first of all. So get the height of A off the ground. So that's where A is going to be. B is next. Here's the height of B. Mark it up. Label, very important. C is next. Mark up the height. And D is going to be at the very top along with E. Okay, so same procedure as the curves below. Project down and 30 degrees from both views to get the curve. Project down over a small bit. So here we have A. B. C, and D is at the very top. And lastly, E. Okay, so I can join those up now. I have D to E, which is going to be 30 degrees, a straight line. Then I can connect up all of my points D, C, B in a freehand curve. Just got this slight wrong point there. Okay. Next I'm going to get, so E goes all the way down as far as this point here, which is in line with the center of the semicircle. So I'm going to find that point here, project it down. So E goes vertically down like that, and it kind of gets hidden. Okay, we won't worry about that a while. Okay, and then I'm going to look at the front of the cab. So I'm going to bring down the line that's under A. So A goes vertically down. So there's that point. And then it goes back 30 degrees until it hits the wheel. Okay, so I'm just going to finish off this detail here where the two of them meet. So the cab, or sorry, the tipper, can heavy that in there. As you can see, it kind of goes back 5 millimeters until it hits the line at E. Goes vertical at that, and then the end of the wheel should go back to there. Okay, tricky old detail, fairness. I'm just going to finish off the back here by drawing in the rest of the wheel, so you won't see the other side of it, so a line at 30 degrees will suffice. Next job is I'm going to get the other side of the cab. So instead of locating all my points A, B, C, D, and E over on this side, I'm just going to get the distance from one side of the cab to the other on my compass. So for example, D to E, or D and E, they're at the top. I'm going to get distance to the other side of the cab. So what I'm going to do is draw like a parallel line over here to the curve A, B, C, D, E, and the rest of the cab. So E, D, C, don't worry if they cross over, B, A. And then at the bottom. Okay, now we can draw in the curve. And heavy in the rest of the detail. I can bring that over as far as the start of the cap. Okay, just for effect, I have shaded in the 3D graphic. Okay, so hopefully you would have got this in under the time limit.